Nigel's a potato pathologist with extensive experience working in the Australian potato industry. He's general manager and principal scientist for the Australian Seed Potato Industry Certification Authority, which is an industry-based organization that operates the seed potato certification scheme in South Australia, Victoria, and Northern New South Wales. In addition to seed certification, Dr. Crump oversees the day-to-day operation of the Talangi Elite business, which produces GO potato mini tubers, and tissue culture plantlets. In addition to the general manager of his Auspica role, Nigel makes significant contributions to the Australian and international potato industry through his many adjunct roles, which include Deputy Chair of the United Nations Economic Commission for Europe, specializing in seed potatoes, and Director, World Potato Congress, as well as Director, Deputy Chair, Potatoes Australia Limited.
So I was going to talk to everyone today very cheekily about the 7 Ps of energy measurement and monitoring. It's really the first steps to assessing energy efficiency. And the 7 Ps, I wonder if anyone could guess. If we're in a live presentation, we might be able to talk about that. But the 7 Ps stand for proper prior preparation prevents piss poor performance. And that's really what we've been doing in our systems and using ag tech to actually capture energy efficiency. It's one thing to capture energy efficiency, it's another thing to actually capture the productivity and maintaining our quality. Just a little bit about Auspica, the company I work for. It's a not-for-profit organisation. It's been in operation since 1994. As Kelly said, our primary role is on seed certification. And what we've done there with ag technology, we've focused a lot on traceability. But we also have another business called Talangi Elite, which produces the high health foundation seed material that's used for the potato industry. About 50% of Australia's potatoes start their life with us. And this is where we've used a lot of monitoring and measurement to actually get that prior preparation, the proper prior preparation, so that we maintain our production. The Talangi Elite business uses tissue culture, so just running through a little bit about what the business does. We use this tissue culture as a high health, virus-free material that gets multiplied up into polytunnels. These are insect-proof polytunnels where we grow the potatoes as they would be grown in the field. We grow many thousands of these plants in various settings. And at the end of the day, this is what we're actually producing, these small G0, Generation 0 mini tubers. And as I said before, there's over 500,000 of them being produced there at Talangi, 50% of Australia's foundation seed supply. There's something like 430 cultivars in our tissue culture collection that we utilise. But in any production system, it's just like Forrest Gump. You know, Mama always said, life's like a box of chocolates. You never know what you're going to get. So we never know what we're going to have until we actually start measuring it. And that's what we needed to do in our production systems. And there's always this balance between productivity and innovation. We can have something that's very energy efficient, but if it affects our production, we can't adopt it. And so we've spent a lot of time actually making sure that we get this right. One thing I actually wanted in our ag tech target was that we wanted to have a system. We didn't want a system that worked on the pump and then something that worked on the greenhouse and something then worked in the laboratory and something worked on the cool room. We wanted one platform. We wanted one management system. I didn't want to learn different systems and the staff didn't want to learn different systems for different operations. So we partnered with Arcoflex, which is a company in Baronia, and our local electrician sector, Seco Electrical, and we actually devised these programs. We've gone a little bit crazy. We've got over 155 sensors and controls managing all aspects of pumps and cool rooms, pressures and water flows and all this sort of stuff. And I'm only going to go through a few examples of these there today. The systems become quite elaborate, and that's why it's good to have that partnership between an engineering firm or software development firm such as Arcoflex and our local electrician in Seco Electrical, and also just working together. So here's one of our systems for one of our polyhouses, which controls all the parameters and monitoring. The Arcoflex system then gave us data that we could actually use. So as I said, that box of chocolates, we're actually working out what we needed to actually understand. Here we're understanding temperature and water movement and electricity use in those polyhouses. But more importantly, as I said before, we could move quite quickly between any operation. So here with a click of a button, we can move between a pump shed, the seed lab, or a given polyhouse. And that's what we actually wanted to utilize here, and we've done that quite successfully. To give some examples in energy efficiency, as that's what Kelly had asked me to talk about today, these examples, here's our cool room. We store for most of the year about all of our production at any one time. So we have close to $1 million worth of product in the cool store waiting for dispatch and distribution. What we used to do internally here, we used to maintain our temperature. The seed potatoes are stored at 3 degrees, but these internal fans in this image here were running 24/7 all the time. The evaporator fans were running. We're actually able to identify, using the monitoring system of looking where our temperature is and looking what fans are coming on, we're able to reduce that fan time by 75% running time. So now those fans are only coming on 5 minutes up while the compressor is running and 5 minutes thereafter. So we're able to reduce that use on those internal fans. But more importantly, we're able to assess what that had on the quality. And this is actually showing you a graph. The light blue line is showing you the time that the compressor is off, and the dark purple is showing the actual temperature of the cool room. And we can see that the compressor is off a lot of the time, which means those internal fans are also off, but the temperature is remaining quite consistent. So we can see the compressor's only running for less than 25% of the time, and the seed potatoes are stored at 3 degrees. And we've actually captured that inefficiency by making fans turn off accordingly, but still maintaining that temperature balance. It didn't stop there with our cool room. What we've also done is we've put switches on doors so that we've actually got it making sure that the doors don't get left open for extended period of times where they're being filled or unloaded. So we have buzzers that go off that remind staff to make sure the doors are closed. We also have the doors opening and closing. And again, the compressor does not run while the door is open. That ensures that cooled air is not escaped from the cool room, actually captures more efficiencies in our cool room, prevents a lot of loss of that cool temperature, but also prevents the condensers from icing. It improves the storage quality, and we've seen better quality mini tubers as a result. So there's another energy efficiency in making the cool room more efficient in its ability to cool those tubers. We also have the lights. There's internal lights, and we make sure they're not left on as well, which not only improves our energy, very minor, but also ensures our potatoes do not grow green under light conditions, and we have that quality assurance. And here again, we can graph that information showing that the doors are open and closed, the temperature is maintained, and we have that control. But also importantly, we have interaction with our staff. It may be a darn buzzer, but the buzzer actually educates the staff on making sure those doors and those functions are actually closed and maintained. We also have risk mitigation built in here too, into the AgTech systems that we're using. And here, just with relating to power, I've selected a few from the dashboard, from our ArcoFlex dashboard. We're looking at our phase variance, our power supply, whether our generators are running or not, whether there's a phase fail relay in the system, an overload trip. Before, a lot of these things had to be manually assessed, and now we don't have to do that because it's all built into alerts on our system. So it actually makes sure that we're actually making sure we don't have that piss poor performance, the parts of the peas. Another example here is our pump. Every day I used to have someone go and assess this pump. It would probably take them an hour and a half. If they had to drive there might be 100 kilometers of driving or more they had to do to assess this pump. Now we can monitor all this and control this remotely. This gives us energy efficiency in what we actually do. We also use UV light to sterilize that water to make sure it's pathogen free, because we have high health potatoes, and we make sure that that's actually running. So we've had savings here. Previously, that hour and a half every day for manual checks, it's now remote management. We have alerts for specific issues. So if a phase fail relay, it'll actually email or call the electrician rather than calling one of us as staff. There's a saving in power and fuel and traveling. But also, again, we're maintaining our quality. We know that our water is sterilized or maintained and pathogen free. And we can do this, again, we can get graphs from the system and show that our system is actually running. The blue line showing when the pump's running, the purple line showing pressure in this particular case. And here we can actually see where the filters are blocked. So it means that we then need to send someone there to replace those filters. In terms of polyhouse lighting and cooling, we've again got our ArcoFlex system measuring the lux that's available in the polyhouse, the light levels. And so we're increasing the photo period for the production, which meant the lights were generally on from 9:30 to 8:30 at night, 9:30 in the morning to 8:30 at night. Now with that lux meter, the lights are only coming on when there is low light levels. So that gives us evenness of temperature, evenness of light, but also we're doing the same thing with the fans. So the fans are coming on and off, and we've made it much more efficient in terms of energy use and making sure things are not being run when they're not required. And this is all being done through our platform. So previously, for example, in the lights, they're continuously on for 16 hours. We've now reduced those hours as required. And the fans and the cooler only run according to temperature and a requirement. We've actually improved those efficiencies by putting multiple sensors in play. What this has actually done, it's actually allowed us to do that remote control. So again, a labor saving. There's alerts to issues, prevention of failures. We've got unnecessary use of resources. So if a fan was left running previously, it'd have to be manually done. Now the system's monitoring it and turning on and off as required. We've seen improved production. We're getting more tubers per plant, which is what we need, better yields. But at the same time, we're saving energy and our resources, not just energy in terms of electricity, but also fuel and labor resources. Here's something where we've improved. This is just looking at temperature in one given polyhouse. The two lines are different sensors in different parts of the polyhouse. And we can see that they're 15 and 10. If we look at the graph on the axis on the other side, they more or less overlay each other. So we see there's uniformity of the temperature within the house, which means we're getting better product throughout the house, better utilization of our cooling resources, which is actually making a better utilization on our energy demands. One little thing I'll just touch on, we've also picked up on safety on this on our AgTech platform as well. We have lights on the outside the polyhouse, traffic light system. Basically, if there's a green light, staff are allowed to enter. If there's a red light only, there's been a pesticide application which is recorded through the ArcoFlex platform. If there's a red and a green light, it means there's a high temperature warning in the polyhouse. For staff, it means that be cautious and don't spend long times in there. The yellow light will mean that the water's been turned off, so it allows for a quick assessment by staff as they're walking by if water is on or water is off. In terms of biosecurity, we've also got alerts there to say whether the two entrance doors are closed. So when someone's walking in, one door must be closed between the other, and that ensures that integrity. So it also ensures that we're not losing a crop due to a biosecurity or an insect incursion inside the polyhouse. So in summary, what we've done in terms of energy efficiency is we've measured, we've done that prior preparation to prevent the piss poor performance. We've mitigated those production risks to actually do that and achieve that. Through doing that, we've increased productivity, and that's been our key goal all the way along. We can't have the efficiencies captured without maintaining or improving our productivity of the mini tubers. And here you can see those mini tubers there on the left again. We've enhanced safety, not only just in terms of energy safety, but also what I mentioned about the entrance conditions into the polyhouses. We've saved labour, many hours of labour, in that previously someone had to go to site to actually see what was actually happening. We now have that built into our AgTech platforms. We've enhanced our biosecurity, and we have evidence of that through that alarm system through the doors. But most importantly, and I suppose that's what we're talking about today, we've demonstrated through what we've been doing here, and we'll continue to do it because we now have the evidence to do it. We know what box of chocolates we have under the Forrest Gump system. We know how we can capture that energy efficiency, and we'll continue to do that. And we can actually challenge ourselves to do it even better. So with that, I'll leave a night view of some of our polyhouses, or a dusk view there of our polyhouses, and I'll hand it back to Kelly. So thank you again, Kelly, for the opportunity to present. Thank you.
Great, thanks, Nigel. That was brilliant. I'm going to allow the one burning question that was pretty enlightening, to be honest. Giant asks, thanks for the presentation. Is there any waste generated in the polyhouses?
Yeah, we have waste. We have waste. The potting mix we only use once, so that's our biggest waste. And then we actually repurpose that to go back to home gardens. So that's actually repurposed. All our plastic from our system is actually recycled. So that's actually done through GT Recycling in Geelong. So our plastic pots and our plastic covers. Our bulk of soil bags are also recycled. Our water, we have very minimum water waste as well. Our runoff is captured and it does go into swale drains, so there's grass that grows in those, but that's only real. And we do monitoring for the nutrient runoff on those as well. We don't want to throw away any nutrients in our system. We've recently just in our tissue culture lab as well, we've recently just acquired Green Lab accreditation, which is an international program looking at energy efficiency and waste monitoring as well. So I think we're one of the few tissue culture labs to actually have that in Australia at the moment. And I challenge everyone to do that. It's an absolutely great system to get involved in, the Green Lab system.
Probably top of the charts. And would you say that you're communicating what you're doing to the growers that you're providing seed to? All this energy efficient measures and
absolutely, sustainability has become a major driver of any agricultural practice. So our customers are like some McCain's and Pepsi and snack brands and others, and they're looking at their platform and their footprint as well. And we've got to be demonstrating we've done that, and that's why this is a great initiative that we've been going through to try and actually, one, measure what we're doing, but then two, measure how we can improve what we're doing.